Hello everyone. This is Anurag Physics Tutorials, and we are covering the IRODOV for electromagnetism. This is electric current, and this is 3.150, and we are solving the resistance cube problems. Now, I've already uploaded a video about the resistance along the body diagonal 2 and 6, and this video is about the S diagonal. And I've already said there are lots of ways of solving the resistance cube problem, but I'm going into the one simpler one, and the next aspect is conceptual one, so that we understand what the stuff is going on. Okay, so let us do here. So this is along the edge. So edge means these 2 points. You can take any points, and so that it will be little easy to visualize it. So I took 1 and 2. You can choose any points on edge, 4 and 3, 7 and 1, and so on. Okay, so now the concept, if you have watched the earlier formula, I've said that earlier video that I've said that we have to find the symmetrical points, and those points will have the same potential. Okay, so the same thing we are going to do here. So, and the way of finding the symmetrical points is by finding the path. So let us take 1, let us take 2. So let us find the path from which we can get from 1 to 2. Okay, so if I go to 7 and I return to 2, this is an edge part 1 to 7, and 7 to 2 it will be a face part. Similarly, if I go from 1 to 4, it will be an edge part, and if I go from 4 to 2, it will be a face part. Now again, if I go from 2 to 3, it will be an edge part, and if I go from 3 to 4, 3 to 1, we are returning to 1, 1 to 2 and 2 to 1. Okay, so it will be a face part. Again, if I go from 2 to let's say 8, okay, so this will be an edge, and this is the face. So this is not the, nothing else is left right now. So now we found out that the 7 and the 4 will have the same potential, and 3 and the 8 will have the same potential. That means these 2 points and these 2 points will have the same potential. Now watch what I'm going to do. I'm going to punch this cube. Okay, in our language it is called pitchkauni. Okay, so I'm going to just punch it so that the 4 coincides with the 7 and 3 coincides with the 8. That means these 2 points will be got folded. Okay, and these 2 will be folded, and these 2 will be folded. You can visualize it. Okay, if I am going to punch it so that the 4 joins to 7 and 3 joins to 8. Now the simplified circuit would look like this. So from 6 to 5 there is a resistance. From 7, so this R, there is a resistance R here, and again the resistance R here. So both, that means these both are in parallel, 6 and 4 and 6 and 7, because these 2 points are identical. That means these 2 are parallel, so combining it I can write R by 2. Okay, R and R by 2. Again similarly we can do this for this R by 2, and then again R by 2. You can visualize which one gets R by 2 and which one remains as R. So okay, again this is R, and then this is R by 2 again, and this is R, and this is R by 2 again. Okay, now let us find it out. So the battery is about these points. Okay, so these 3 are in series, right? So R by 2, R, and plus R will be R by 2. Sorry, 2R. Okay, so this is 2R, and 2R and R by 2 are in parallel. Okay, so this can be replaced by 2R. This can be replaced by 2R, and 2R and R by 2 will be in parallel. So solving it, we get R net for this system equals to 2R into R by 2. It will be R square divided by 2R plus R by 2, 4R plus R, 5R by 2. So 5R, it will be 2R by 5. So I can replace the system by 2R by 5. So 2R by 5. And again these are in series, and this in parallel. Okay, so R by 2, R plus 2R by 5 will be 7R by 5. Okay, so this is 7R by 5. Now I don't need to draw these 2. Now finally we have to add this. So 7R by 5 plus into R divided by 7R by 5 plus R, it will be 12R divided by 5. So it will be 7R divided by 12. So along the edge, the net resistance is 7R by 12. Okay, what we did, we found the symmetrical points, we found that they are in parallel, and then we applied the formula for parallel, and we simplified the circuit, and we got the answer 7R by 12. Okay, thank you. Let's meet in another video. We are covering one more is remaining, and we'll finish it. Thank you.